All right, and welcome back. And we are going to be starting to talk about quadratic functions. Personally, I love quadratic functions. We are going to be talking about curves, and it's going to be so fun. So far, we've only talked about linear functions, where we have a straight line. Well, now we're getting curvy, so it's really, really interesting. There are some aspects that can get a little bit confusing, but I know we're going to push through it because we are rock stars. So let's have out our guided notes for section 8.1. Let's talk about how to identify quadratic functions. So there are 3 steps to identify a quadratic function from a table of ordered pairs. I'm going to show it to you all and we're going to break it down. So the question asks us to tell whether the function is quadratic and explain. The first step, I'm going to circle it in red, is to check for a constant change in our x values. Well, if we look, we have that constant change in our x values we're adding to as we go down the list. Step 2, I'll circle that in green for you. We want to find the first differences in the y values. So you're going to notice over here in green, we found the first differences. We take the differences between the two and we keep on going down. And you're going to see that there is not really a pattern here. There isn't a constant change, and that's good. We don't want a constant change. If they're constant, the function is linear. Thinking back to having slope is a constant change in our y divided by a constant change in our x. Well, we don't want a straight line. We are talking about curvatures now. So we don't want to have a constant change. And that third step, and this is where it gets cool, we're going to find the second differences in the y values. So now that we have those change in the y values, we're going to find the differences between them. So in that first example, we did 60 minus 132. That's the first difference of the two y values. Then we keep on going down, and we're going to see that those are going to be constant. So if the second change in the differences in y values are constant, then it's going to be quadratic. If it's the y values have a constant change as the first difference, it's going to be linear. If we have a constant change in the difference of the second, then it's going to be quadratic. Awesome. With this, please work on problems 1 through 3 on the guided notes and resume when you're ready to move on. All right, so now let's talk about how to find the domain of a quadratic function. Your guided notes are going to tell you to flatten the parabola towards the x-axis, and to find the range, we flatten the parabola towards the y-axis. Then we're going to read the domain and range from the inequality graphs. I have a little bit different of a way, so I'm going to talk to you about the way I do it. Let's say we are given this graph, and this is again pulled from your guided notes. On the left-hand side, we have a quadratic function. We call it a parabola or a parabola if we are feeling silly. One thing that we're going to find is that the domain, remember, is the change in x values. It's the total possible x values that we could have. Well, for a quadratic represented by a parabola, it's always going to be all real numbers. It'll always be all real numbers. The way that I find it is I look at the arrows. If we have arrows that are pointing up or possibly pointing down and seem to be going at an angle going outwards, then we can have any possible x value that we want to. So your domains, 99.9% of the time, are going to be all real numbers. If it's a true quadratic, it's going to be all real numbers. The only time that we might see something different is if we have something that looks like this. If we have a function that looks like that, that's not a true quadratic function, but in that case, we would have to quote unquote flatten and look to see, hey, what's the smallest x value possible and what's the biggest x value possible? And that's going to be our inequality. But again, 99.9% of the time, we're going to have a domain that's all real numbers. Let's talk about the range. So we're going to be talking about the range here. So the range, it asks you to flatten towards the y-axis. And again, that is a viable strategy. But here's the way that I do it. I'm going to look at our quadratic and I'm going to say, okay, what is the lowest or the biggest point? So we can see that we have the arrows up on top. You have the arrows that are going up, which means that we're going to be increasing forever and ever and ever. That's what arrows mean. So what I do is I'll go to the bottom and I'll see, okay, at what y value is the lowest part of our parabola? Well, the lowest part is going to be when y is 3. But since we're going up, our y is increasing. So it's going to be y is greater than or equal to 3. Because the lowest possible value that we could use is 3, but we keep increasing and going up and up and up. So it's going to be y is greater than or equal to 3. So 5 works, 10 works, 100 works, 427 works, 375,462, that's a possible y value because we're going up and we keep on going forever and ever and ever since those arrows are pointing up. Now, if our arrows were pointing down, we would be trying to find the biggest y value. So if this was flipped, let's say we flipped it in the green, well, for this one, it'd be y is less than or equal to 3. Since we're going down, our y values are going smaller and more towards those negatives. Awesome. With this, please work on problems 4 through 6 on the guided notes. Y'all are doing super duper well. Hopefully we're going to find a love for parabolas because I'm silly. If you have any questions, please do not hesitate to let me know. Other than that, talk to you soon.